The x and y coordinates of the particle at any time are x is equal to 5t minus 2t square and y is equal to 10t. Where x and y are meters and in seconds, the acceleration of the particle acceleration at t is equal to 2 seconds. Okay, so in the examination hall, all what we'll do is vx is 5 minus 4t, vy is 10, so ax is minus 4 and ay is 0 and a is root of ax square plus, okay, we're doing for the examination purpose, so a is just minus 4, so a is a constant and is not proportional to time, so minus 4 is correct answer, less than 1 minute, as simple as that. But let us now understand how to approach this question. Basic differentiation it is. So it's given to us that x is equal to 5t minus t square and y is equal to 10t, right? So it means that the displacement has two components here, the x component and the y component. So if you differentiate the x component with respect to time, what do you get? Velocity of the body in the x direction. If you differentiate the y component with respect to time, what do you get? Velocity of the body in the y direction. When you differentiate velocity of body in the x direction, you get acceleration of body in the x direction. When you differentiate velocity of y with respect to time, what you get is acceleration of body with respect to time, right? So dx by dt will be equal to d by dt of 5t minus 2 into d by dt of 2 square, and dy by dt will be equal to 10 into d by dt of t. So dx by dt is equal to, see, 5 into derivative of d by dt of derivative of t is 1, so it is 5 into 1 minus 2 into derivative of t square is 2 into t to the power 2 minus 1. Similarly, dy by dt is equal to 10 into d by dt of t is 1. So dx by dt is nothing but vx and dy by dt is nothing but vy. So vx is 5 minus 2 into 2 is 4. 4 into 2 t to the power 2 minus 1, which is 4t, and vy is equal to 10. Now if vx is this 4 minus t and if vy is 10, if we differentiate further, what do you get? D by dx of vx and, sorry, not d by dx, d by dt of vx and d by dt of vy. So d by dt of vx would be d by dt of 5 minus 4 into d by dt of t, and here it would be d by dt of 10. See, what is d by dt of a constant? It is equal to 0. So this is equal to 0, and d by dt of 5 is also equal to 0. And what is d by dt of vx? It is ax. So ax is equal to minus 4 and ay is equal to 0. So if a vector has two components, ax and ay, then what is the net vector? Net vector is equal to ax square plus ay square. So this will be equal to root of minus 4 the whole square plus 0 square. So a net here is equal to 4 meter per second square. And since ax is equal to minus 4, since there is no t involved here, this means that acceleration is not varying according to the time, or in other words, acceleration is a constant. Okay, now the next question.